Okay, how you doing? So check your answers with this one here, and let's review really quick. This is the first one, the series circuit. Let's think about how currents work. Um, Current is the electrons moving through, so once they start, they're going to go through every resistor. For the voltage, the energy, and the energy is going to get lost between all those resistors, equaling to the total the battery started with. So the two voltages you have would add up to be the beginning. And how resistors work in series is they just add together. In parallel, let's write those down here. The current you start with, the total, it's going to be able to branch off. So those two other currents add up to be the total you started with. Right here, the voltages, well, each electron only gets to pick one of those resistors to go through. No matter which one it goes through, it's going to lose that energy it gained from the battery. So all the voltages in the different branches would be equal. And finally, to find the overall resistance. In parallel, it lowers the resistance as you keep adding resistors. So the equation looks like this. And then remember, remember to flip that over when you're done, because this way you're going to find 1 over the total. You want to flip it around in the end. The other thing you want to remember is that Ohm's law, I equals V over R, is always true for both kinds of circuits. So you can rearrange that also to find the voltage, I times R, or the resistance, V divided by I. And power, that's just I times V, and that's for both circuits also. So let's see what we got here. On this first one, we have the total voltage. We have this first current, and they also told us this first resistor here. That was 5 ohms. So what can we find? Well, we know in series, all the currents are equal. So because I know one of these currents here, I should be able to find the other ones. They're all equal. What else would I be able to find now? Well, I can find this total resistance because I know 2 out of these 3 things here. I know the V and the I. I can find the R with this equation right here, V divided by I. So V divided by I is going to give me 20. 10 divided by 0.5. Now what else can we find? I can find, let me go back here, sorry. I can find this missing resistor here, R2. Take this equation. To get R2 on its own, you would subtract R1 from the total. So take 20 minus 5, that means this has to be 15. Now how would we get these missing voltages? Well, Ohm's law again. V is I times R. So 0.5 times 5, I times R is 2.5. 0.5 times 15 is 7.5. You could check that answer because how voltages work in series, they add together to be the total. So if I add these two up, let's check this equation, 2.5 plus 7.5, yeah, it gives me 10. So that works out well. Now the power is just I times V, so 10 times 0.5, or 2.5 times 0.5, or 7.5 times 0.5. And that would be 3.75. Okay, so let's look at this parallel one here. What do we have at the beginning? We know this voltage, we know this resistor, and this resistor. The only thing we can find right now is this total resistance. So what we got to do is use this equation and say that the total would be 1 over 20, 1 over 60. You have to find a common denominator or know how to, I'm sorry about this, or know how to fit that in a calculator. But 1/20th is the same thing as 3/60ths, plus the 1/60th would give me 4/60ths. But then you have to flip that over because you just found 1 over the total and you want just the total or 1 or the total. So 60 divided by 4 would give you 15. Overall, this total resistance always has to be less than your littlest resistor. This 20 was the smallest resistor. That's going to be less than that 20. So it's pretty accurate there. Now that we know the V and the R for the total, we should be able to find the I. I is Ohm's law, again, V divided by R. So I could take 6 divided by 15 to get that answer. Okay, if I take that 6 divided by 15 to get the I, I'm going to end up with 0.4 amps of current. Now we know that in parallel, the voltages are all equal. So these would all be 6. And I can find the I in the same way by taking V divided by R. So 6 divided by 20 would give me this one, which would be 0.3. And 6 divided by 60, 0.1. I could check that answer because these two currents should add up to be the total in parallel, which it does. Power is just I times V. So if you took 0.4 times 6, that's going to give me 2.4 here, or 0.6 times, 6 times 0.3, that would be 1.8, or 6 times 0.1 gives me 0.6. Let's look at this next resistor here. This is a series. So what do we know? We know this first R, we know that second one, we know the third one, and we know this current right there. It's a series circuit. So we should realize that all these currents have to be the same. What can we find next? We can find these V's. Go back to Ohm's law right up here. V is I times R. So if I take 6 times 2 for this bottom one, it would give me 12, or 6 times 5, or 6 times 3. This one's missing, but I can find it by adding up all these voltages. That's how it works in a series. They all add up to be the total. So 30 plus 18 plus 12, that would give me 60 volts. Now this total here, I could do two ways. I can add these all up because it's series and they should add up to be the total. Or R would be V divided by I. So if I took 60 divided by 6, that's another way of getting that 10. Then the power, I times V, so 6 times 60, 360. 18 times 6, not that good, so let me put that in my calculator here. So I have 18 times 6, I get 108, or 30 times 6, 180, or 12 times 6, 12 times 6, 72. Okay, this last one, parallel circuit. They tell us the initial current. Say this is 15 and 15 and 5. Only thing I can find right now is this total resistance again. So I have to add that up in parallel again. They don't just add together. I'm going to use that equation and say 1 over 15, 1 over 15 plus 1 over 5. I'm going to find a common denominator, which would be 15. So 1 over 15 plus 1 over 15, and 1/5 would be 3/15. Add that together, and you would get 5/15. That's finding 1 over the total. We want to find the total of the total over 1, which would be 15 divided by 5, or 3 ohms. A kind of a self-check really quick is that it's less than 5, so that seems like it could be pretty accurate. How can we get this first voltage here? I have the current and the resistance. And voltage is I times R, so 10 times 3. This is a parallel circuit, so we should realize that no matter which way this current goes, it's going to lose that voltage through any one of those resistors. So they're all going to equal the same voltage. And then the current, we know that it splits up now. I start it with 10 amps, so many electrons, and some get to go down the first branch, some down the second, some down the third. We can find that though because we have the V and the R. I is V divided by R. So if I took, say for this first example, 30 divided by 15, I get 2. 30 divided by 15 again, or 30 divided by 5. I can check my answer because all of these currents should add up to be this total current. Also, let's see if it makes sense with the resistors. This 5 ohm has 6 amps. This 15 has 2. Yeah, the smallest resistor is going to have the most current. And this actually is, say, 3 times the resistance of this. So look at the current. The current is 3 times less than that one. Power is just I times V. So 30 times 10, or 30 times 2, 30 times 2, or 30 times 6. That's a 180. Okay, hopefully you got some good answers there. If you need some extra help, I'll be on Zoom or email me, and I'll be ready for a quiz tomorrow. Okay, take care. Bye.